1.3, Introduction to Function. We'll start with definition. A relation in which each x coordinates is matched with only one y coordinate is said to describe y as a function of x. So we say a relation in which each x coordinate is matched with only, I'm going to underline only, with only one y coordinate is said to describe y as a function of x. So example, which of the following relations describe y as a function of x? Which is a function, y is a function of x, which is a function. So A, the first relation, R1, has elements -2, 1, 1, 3, 1, 4, and 3, -1. So is this relation corresponds for each x exactly 1 y, -2 goes to 1, 1 goes to 3, but notice this, 1 goes to 3 and then 1 goes to 4. So that is a problem, and we say this is not a function because we don't have the exact correspondence. B, a relation called R2 has the following elements: -2, 1, 1, 3, 2, 3, and 3, -1. So is this a function? -2 goes to 1, 1 goes to 3, 2 goes to 3, 3 goes to -1. Yes. So we have a test called vertical line test that helps us decide whether a graph represents a function or not. Vertical line test. If I have a graph, let's say I have a circle, and if I draw a vertical line anywhere, and if that line intersects the graph in more than one point, then this is not a function. Because for this x, you have 2 y's, not a function. Now, if I have a graph, let's say a parabola, draw a vertical line, exactly 1 point, so yes, this is a function. Each function has domain and range. So the domain is the set of x coordinates or x values, and range is the set of y coordinates. So example, if I have this function, I'll call it f with the following elements: -3, 2, 0, 1, 4, 2, 5, 2, and we want to find the domain and the range. So the domain will be the set of all x values, -3, 0, 4, 5, and the range is the set of all y values, 2, 1, I don't have to repeat 2 again, so that's it, 2 and 1. We often have to find domain and range from the graph. So if the graph is given, and make sure that the graph represents a function, and this one does. If you try the vertical line test, you intersect the graph in exactly 1 point. So this graph ends at the point 2, 3. In fact, this is, okay, it's a filled-in circle, so it's included. So to find the domain, You look at all x values. So we start from left to right, from negative infinity to 2, including the 2, because it's a filled-in point here, 2, 3. Okay, and the range, I do need this point right here. So that is 1 and 3.5. See? So the range is the y values, the set of y values. You go from bottom to top. So it's from negative infinity to the highest point is 3.5, including. Sometimes you have to find the domain and range from the equation, but now we're gonna answer the question whether the equation represents a function or not. Determine which equation represents y as a function of x. A, x to the third plus y squared equals 1. We don't have to graph it. What we need to do is solve for y. So y squared is 1 minus x to the third. And y is equal to, if I square root both sides, I need to do plus minus. And I have two equations for y. So for each x, you're going to get two different values. So we say not a function, because each x will produce two different y's. B, x squared plus y to the third equals 1. Very similar. But now when you solve for y to the third, 1 minus x squared, and cube root both sides. But when you cube root both sides, you don't need the plus minus because it's an odd function. So for each x, you have exactly one y. So this is a function. And this concludes the section 1.3.